Once upon a time, there was this beautiful girl, Amy. She was the only daughter of the CEO of the world-renowned company, Shelley's Insurance. Apart from messing in her dad's company, playing computer games in office, she enjoys some more extreme activities like bungee, parachuting, surfing, and others. On a Saturday morning, she was bored at home, so she phoned her friend.
Hey May, why don't we go to Chimsha amusement park? Let's ride the scariest roller coaster in the world.
Her friend agreed, so they set out for Chin Short. Meanwhile, we have here Leo.
Hi there.
Leo was a paid assassin. His master hated Amy's dad and wanted to make him mad, so Leo was ordered to assassinate Amy.
I'm going to kill Amy, and let's get going.
So Leo also went to Chin Short. There he found Amy, riding the scariest roller coaster in the world.
Never be an assassin. You could only watch others doing the fun part. But I have to feed my cute little daughter. Anyway, back to work.
Leo reckoned that it was the best to shoot Amy while she is on the roller coaster. But the scariest roller coaster in the world has that one part that runs on a nice big parabola and dives into water for a brief period and comes out.
Which is a problem. Water does no good to my shooting. I'd better figure out when the ride is water-free.
And he failed. So he took out his phone and called his friend David.
Hey, Professor.
Stop calling me professor.
I need your math power.
No, I'm afraid I can't help. I have some urgent business to do, like hacking WeChat and saving the world or something.
Alright. I'll buy you pizza.
Deal.
I'm at Team Swords, and I have a target I would like to shoot while she is on the scariest roller coaster in the world. She will go through some water that I would like to avoid. I suppose you've heard of the scariest roller coaster in the world, right?
Yeah, and it does have a parabolic part that touches the water.
I want to know how to derive a time when the roller coaster is not underwater at the bottom. I want the method to figure out the right timing she will dive and come out.
Is it just me, or do I smell grade 11 pre-calc math in the air?
You want your pizza or not?
Okay, I think that's a one-variable quadratic inequality. Quite easy. Let's use the inequality x squared minus 4x plus 3 is larger than 0, just as an example. I have 3 ways of solving it. Which one would you like?
Duh, the easiest one, of course.
Well then, take out your graphing calculator. Graph the roller coaster's height against time. Simply observing the graph gets you the answer.
I see. In my case, I want a part of both water. I want it before it enters the water or after it leaves water. I would just have time to be less than the first point where the graph emits the x-axis, or greater than the second point where the graph emits the x-axis. And that's it. Amazing!
Don't forget to buy me pizza.
Wait a second. I don't have a graphing calculator. I can't afford one.
Well, you should have told me earlier. But don't worry, use case analysis. Factor the quadratic expression to rewrite the inequality. The product of two factors is negative when the factors have the same signs. There are 2 ways for this to happen. Case 1. Both two factors are positive. X minus 1 is greater than 0 and x minus 3 is greater than 0. Solve these inequalities to get x is greater than 1 and x is greater than 3. Any value that satisfies both conditions are part of the solution set. These conditions are both true for all values strictly greater than 3. Case 2. Both two factors are negative. X minus 1 is less than 0 and x minus 3 is less than 0. Solve these inequalities to get x is less than 1 and x is less than 3. Any value that satisfies both conditions are part of the solution set. These conditions are both true for all values strictly less than 1. Therefore, the solution set is x is less than 1 or x is greater than 3.
What the?
Or you could use sign analysis. Again, factor the quadratic expression for x squared minus 4x plus 3 is larger than 0. Determine when each of the factors x minus 1 and x minus 3 is positive, 0 or negative. X minus 1 is negative when x is less than 1. It is positive when x is larger than 1. Do the same for x minus 3.
Okay, x minus 3 is negative when x is smaller than 3. It is 0 when x equals 3. It is positive when x greater than 3.
Correct. Then sketch number lines to show the results. From the number line representing the product, the values of x less than 1 or greater than 3 satisfy the inequality x squared minus 4x plus 3 is larger than 0. So the solution set is x is less than 1 or x is greater than 3.
Well, that was an effort. I think I got it. Let me try with a roller coaster one. Okay, I need the inequality of a roller coaster. There it is. Hey, how do I factor that thing anyway? 0.403x squared minus 3.15x plus 5.65.
Well, I think that's an issue.
Do you have any method that actually works? Cause I'm...
Calm down. I have one last method. Roots and test points.
Oh, okay. Roots and test points.
Solve the related equation. 0.403x squared minus 3.15x plus 5.65 equals to 0 to find the roots.
You know what? Why don't you just solve it for me?
Yes, I'll solve it for you. Use the quadratic formula to obtain the roots. A is 0.403, B is minus 3.15, C is 5.65. Substitute the numbers into the quadratic formula and we get x1 is approximately 2.79 and x2 is approximately 5.03. Plot the solution on the number line. Use open circles since these values are not solutions to the inequality. The x-axis is divided into 3 intervals by the roots of the equation. Choose one test point from each interval, say 0, 4, and 10. Then substitute each value into the quadratic inequality to determine whether the result satisfies the inequality. Use the table to organize the results. The values of x less than approximately 2.79 or greater than approximately 5.03 satisfy the inequality. So the solution set is x is less than 2.79 or x is greater than 5.03.
Got it. Now I have to wait just 3 more seconds.
That was the scariest ride I've ever been through. The parabola part that touches the water was my favorite. What's next? Let's ride again.
Here's my chance. I'm not losing it. Now! I left my ammo home!
Ha! Can't help you this time.